Okay, so like I said, we're starting the next chunk of content, like the next module, which will go from 9.1 to 10.1, 9.4 to 10.1. 9.4 is called parametric equations. That's what we're going to talk about today. 9.5 and 9.6 are about polar points and then graphs, and then 10.1 is like 3D plotting points, x, y's, and z's. So 9.4 is called parametric equations, and a parametric equation is a set of equations, so it's a system, a set of equations that express a set of quantities as explicit functions of a number of independent variables known as parameters. The variable we're going to use to introduce this parameter is t, which represents time. So in these systems, you're going to get x's, you're going to get y's, and you're going to get t's. And again, t's represent time. Not like time as in 60 seconds, like 1 is not 1 minute or 1 second, it's just a representation of a unit of time passing. So they're not specific times like seconds or minutes or hours, but simply a unit of time. So if t is 0, then we haven't started yet, and then t is 1, we're 1 unit later. So you're going to see there's 3 different types of questions or 3 different types of problems in this section. Some of them involve graphing, and some of them involve the systems of equation. So this is the difference between a parametric graph and a rectangular graph. So if we just focus on the graphs for a second, on the right is what we're used to. This is called a rectangular graph. This is your parabola. You're plotted on an XY coordinate system. Okay, this equation is y equals x plus 3 squared plus 1. That's a parabola that points up. Okay, it's got arrows on both ends because it continues on either direction. On the left, this is a parametric equation. Notice that there's 2 equations. It's a system. The first one says x equals t plus 3, and the second one says y equals t plus 6 squared. God bless you. Plus 1. I'm going to teach you how to graph this. But notice that it doesn't end both sides with arrows, that these arrows actually go in a direction, and that's because your unit of time is moving in that direction. So it starts at a certain point, like t being 0 or whatever it is that you're plugging in, and you're going to advance until you're finished with those points. So when you graph parametric, they have to have those arrows to show the orientation, okay? And then you're going to see we're going to approximate graphs using rectangular. So you're going to do both of these in this section. So it says plane curves are continuous functions whose graph can be traced without lifting the pencil from the paper or the stylus from the iPad, okay? There's not holes. It will go from start to finish. The points are plotted in the order of increasing values of t, and arrows indicate the direction or orientation of the curve. So the arrows are pointing away from t being 0 and to the bigger t. All right, so this is basically what we kind of just said in math speak. It says if f and g are continuous functions of t on an interval I, then the set of, God bless you, then the set of ordered pairs is f of t and g of t, God bless you. So you will actually determine your x and y coordinates by taking the t values and plugging them in. So normally with whatever's inside that parentheses is what we would take and plug in. We were going to plug it into the x, we're going to plug it into the y equation, and then you'll get an x and y coordinate, and those will be your points that you're going to plot. So you'll get a t-chart that will look something like this. The first column is t, that's the variable, that's the number that you're going to actually plug in for. And then what you plug into the x, you're going to get the corresponding x, plug into y, you'll get the corresponding y, and then the xy coordinates is the function that's going to be created from there. So this one I already give you the t-chart, okay? So sometimes I give you the t-chart, sometimes it's going to give you the range and you got to figure out the t-chart. But we'll start kind of easy. It says sketch the curve given by the parametric equations x equals t squared minus 4 and y equals t over 2, given that negative 2 is less than or equal to t, which is less than or equal to 3. So this means that my range for t is starting at negative 2 and going up to 3. So those are the values that you're going to plug in that very first column. Negative 2, negative 1, 0, 1, 2, and 3. And then you are plugging those values in twice, once for x and once for y. So if I plug all those values in for x, I would get x equals negative 2 squared minus 4 which is 4 minus 4, which is 0. And then I go to the next one. X equals -1 squared minus 4, which is 1 minus 4, which is -3. And then I go to the next one. X equals 0 squared minus 4, which is -4. Next one, x equals 1 squared minus 4. -3. X equals 2 squared minus 4, which is 0. And x equals 3 squared minus 4, 9 minus 4, which is 5. With me so far? Now I'm repeating that whole process this time for y. So y equals t over 2, which would be -2 over 2 or -1. Y equals -1 over 2, which is -1/2. Y equals 0 over 2, which is 0. Y equals 1 over 2. Y equals 2 over 2. And y equals 3 over 2. And then that last column is just the combination of those two. 0, -1, so the x and the y for each one. -3 and -1/2. -4 and 0. -3 and 1/2. 0 and 1. And 5 and 3/2. And then I plot those points on my graph. So 0, -1, -3, -1/2, -4, 0, -3, 1/2, 0, 1, and then 5, 1, 2, 3, 4, 5, and 3 over 2, or 1 and 1/2. Everybody still with me? So I need to connect those points in the order in which they were given to me. So if I'm going from the very first one, which is on the bottom, all the way around to the end, it looks like almost like a parabola that's turned on its side, but it's restricted. And my arrows, so you have to include the arrows on parametric, would go away from the first T and point to the last T. If it didn't give me a restriction to stop at, then that last one would be an arrow. But because it told me to stop at 3, that last point is an end point. So it gets an actual solid point.
So where do you know where to put the arrows? Does it matter?
So it's away from your first T towards your last T. The location on them doesn't matter. Yeah. And I would say 3 is fine. Like there's not a set number that you need to put. You just have to establish that orientation. Questions? Back to plotting points, right? Easy stuff. You just got to remember the arrows, because if you don't have the arrows, you will lose points. So it's been a little while since we used our graphing calculators, but if you have them with you, you can take it out. I'm going to show you how to graph a parametric function. All right, so the first thing we have to do is tell your calculator that we're now in parametric mode, okay? So up to this point, we've only gone through radians and degrees, right? But if you click on the mode button, underneath radian degrees, it says function, parametric, polar, and SEQ for sequence. I'm going to parametric. So I'm going to scroll over to where it says parametric, and I'm going to hit enter. So I just switched my calculator's mode, okay? So remember that it's in that mode now so you don't like freak out later when it looks like weird, okay? And when we get into polar, notice that's where polar is too because we're gonna get back there. Then I'm gonna second quit to get out of this menu. Oh, let me. Okay, so now I wanna type in my equation. So I click y equals like I normally do, okay? And notice that now my actual graph or my actual window includes, one, there's t's there, but two, each little color or each number, each equation has two, right? It has an x and has a y. Normally it just has the y equals. So we're gonna type in like we just did. So I'm gonna do them like what we did in the last example, which was that t squared minus 4. When I hit the x, t, theta, n button, which is my variable button, now I get a t instead of an x. So let me go up here. I'm gonna hit that button, t, if I want it squared, obviously square it, minus 4, that was the first equation. And then y was t over 2. So t divided by 2, hit enter, and then hit graph. Does it look like ours did? A little bit, but not exactly, right? It's actually restricted. Does that make sense? You see that it's cut off, right? At the wrong spot. So if you click on your window, which is what causes the restriction, your T min and max don't match what our T min and max were. What was our min? -2. So if I change it to -2, and what was our max? 3. Now I go back to the graph, and now it looks like ours does. So if you restrict it the way yours is restricted, it should look exactly the same. Except what? What's missing? The arrows. Your calculator is smart, but it's not as smart as you. Okay? It doesn't know the orientation. If you use this, obviously in here you're just going to use it to check. You wouldn't use it on your actual test. If you actually used it to graph one, then the way that you can figure out your orientation is to go to your table. So if I go second table, it's going to bring up my values. So I noticed that at -3, it's 5, -1, 1.5. And then it's going to increase till I get to 2 would be 0, 1. So I would know where the start is at 5, -1.5. And the end is at, where did we go? Oh, we went to 5 and 1.5. So when I go back to my graph, I would know which direction to put the arrows in. But again, at this point, you're only using this to check your graphs. Questions? Okay, and then we're gonna come back. Don't worry, we'll go back to that menu for when we get to polar. All right, now you do this one. So same set of instructions. Sketch the curve given by the parametric equations. X equals 4t squared minus 4 and y equals t. Given now the restrictions -1 to 3 halves. So you actually have more rows there than you need, okay? You just start with -1 and then make your life easy and go by whole numbers. Then go to 0, then go to 1, then the last one would be 3 over 2. So you've got a fraction there, but that's plenty. That's enough. Okay, should look like this. So when you plug in -1 to x, you got 0, then -4, then 0, then 5. For y, it is the t. So -1, 0, 1, and 3 halves. and then you plot your points, and then you make sure to include the orientation, which is pointing away from that 0, or the -1 actually is the smallest this time, and pointing towards your 3/2. Raise your hand if you got it right. Okay, questions?
You can always put like more points.
Sure. Like in between? Yeah. Yeah, more's fine. Less is a little rough, but more's fine. Yeah. Okay, so that's the first kind of question in this section. Second kind is called eliminating the parameter. So you can actually represent that curve by adjusting your initial equations to eliminate t, and then graphing what's there, which will be an approximation of your graph. So it is not as accurate as what we just did. What we just did would be the most accurate way to graph it, okay? But what we will do is eliminate the parameter, and the parameter again is t, so we're eliminating t, by solving one of the equations for t, just like we would do with the systems of equation, and then plug that into the second equation to eliminate the t from the second equation. And you will get one ending equation, that's the combination of the two. And you will only have x and y. So then depending on whatever equation's left there, you will know how to graph it. You'll graph it, okay? But you won't have the orientation. So these don't have the arrows in the directions that they're supposed to go. That's why it's an approximation and not exactly accurate. And then the last thing says the domain and the functions may need to be restricted to graph accurately. So keep in mind domain is going to be important here. So how do you know that something's domain has to be restricted? It's been so long since we talked about domain. What are the things that restrict domain?
Can't equal 0.
Okay, a denominator can't equal 0, right? So if a variable's in the bottom, it can't equal 0. And there's one, well, there's two other ones technically.
Can't be negative, right?
A square root can't be negative, and then the combination of those two, right? So if you're looking at your original equations and you see that there's a variable in the square root, you've got to make a note of that domain. If you've got a variable under the denominator, you make a note of that. If you've got the combination of the two, then you would adjust those, okay? So keep that in mind when you're going to graph these. So example 3 says graph by eliminating the parameter. So the first thing I have to do is actually eliminate it. I'm going to look at the two equations that are given to me, and I have to solve one of them for t and then plug it back into the other one. So looking at these two equations, which one would be easier to solve for t? The second one, right? Like the first one I'd have to add the 4 and then square root, which is not fun because you have to do plus and minus, right? But the second one's not so bad. So I would just multiply both sides by 2. And I would get 2y equals t. And then I want to take that and I want to plug it in to the t in the second equation. So I would get x equals 2y squared minus 4, which is 4y squared minus 4. As soon as you get there, hopefully, because it hasn't been that long since we talked about conics, you recognize that this is a parabola. I have one variable that's squared. The y is squared, which means it's going to be pointing right or left. But this isn't in standard form yet to know which direction it is pointing, between the right or left. So if you want to get it into standard form, you're going to work so that the y squared is on the side by itself. So I'm going to say that x plus 4 would equal 4y squared. And then I would divide both sides by 4 or multiply by a fourth. And we've been programmed to see the squared on the left. If you want to rewrite it, you can, but you don't have to. So now that's in standard form. So tell me about this graph. Which direction is it pointing? If it's y squared and the 4p's positive. To the right. Okay, where's my vertex? Negative 4, 0. Okay, so right there is my approximation. I'm going negative 4, 0, plotting a point, and I'm pointing my graph to the right. It's an approximation. And that 1/4 being 4p tells you that the actual p value is 1/16, right? So if I was to graph a focus or a directrix, just because that should be hopefully a little fresh in your mind, it's only 1/16 away. It'd be a teeny tiny distance, okay? But when we're doing these, we are just approximating. We don't know orientation, so I don't know where to put the arrows along the curve, so they go at the ends where they're supposed to. Questions on that one? Okay, and then obviously they just get a little bit more complicated. Same set of instructions, graph by eliminating the parameter. But this time I've got square roots and I've got fractions. So hopefully a red flag goes off about your domain, right? For this one, I've got a square root in the denominator. So I would say that the square root of t plus 1 has to be greater than 0. If it was in the numerator, it would be greater than or equal to 0, but because it's in the denominator, it's greater than 0. Just what's underneath it, sorry, the t plus 1. So then t would have to be greater than negative 1. That comes from the first equation. And then the second one, the problem is there's a t in the bottom. So t plus 1 cannot equal 0, and t cannot equal negative 1. Because the bottom can't be 0. So now the actual restriction comes from the overlap of these two. Okay? The left one says it has to be greater than negative 1. The right one says that it can't equal negative 1, which means the left one is already taking care of the right. Like the left one already excludes negative 1. So you always want to go to the one that restricts it more, right? So my domain here is that t has to be greater than negative 1. That had nothing to do with graphing it yet. That's just your domain. On the last one, there was no domain restriction. So if you look at your, like it actually gives you multiple choice on the domain restriction on the homework, it's not necessary. If there's no restriction, you don't put that it's in negative infinity, positive infinity, you would say that the restriction's not necessary. So that's one of the choices. Okay, so now I've got to go through the actual elimination of the parameter. So look at these two equations. Neither of them are necessarily easy to solve for t. Let's choose one. Which one would you want to do?
Y equals.
The y equals? Okay, so if I did y equals, well, let me go ahead and multiply it out. So I'd multiply by t plus 1, t plus 1. I get y times t plus 1 equals t. And then I've got to distribute the y, so I get y t plus y equals t. I got to get both t's to the same side, so I get y equals t minus yt. Factor out the t. And then divide both sides by 1 minus y. Okay, so now I want to take what t equals and plug it into the other equation in place of the t. So I'm going to take this and I'm going to plug it into this t. I get x equals 1 over the square root of y over 1 minus y plus 1. Now I got to simplify this. So how would I get rid of the square root, first of all? Square both sides. So I get x squared equals 1 squared, which is 1, over the square root squared eliminates the square root. And now I've got a complex fraction. I got a fraction within a fraction. Can't do that. So I got to change this so that it has a like denominator, 1 minus y. And I get x squared equals 1 over, combine these numerators, y plus 1 minus y. The y's cancel. And I get 1 over the denominator, which is 1 minus y. And then I'm dividing by a fraction, so I'm going to flip. So this is gone. And then the y's obviously, 1's canceled, not that it matters, but it would be 1 either way. Equals 1 minus y. Now again, it's a parabola, right? It's almost in standard form. I would just have to switch the order here. And take off that negative 1 because y has to be by itself. So what direction is this parabola facing? It's an x squared with a negative 4p, right? So it's pointing down. So my vertex, which is 0, 1, would be here. And then I'd have to point it down. And again, that's an approximation, so there's no orientation. And the graph doesn't have the domain restriction. Because we don't know where t equals 1, this is an xy chart, not a t on here, right? We don't know where t equals 1 in order to restrict this as it is. If you wanted to know exactly where to restrict it, you would have to plug in where -1 is, right? It has to be greater than -1. So I'd have to plug in -1 to both of them, get that coordinate point, and then I would know where to restrict it to if you want it to be more accurate. But for these, this is just an estimate. So you're just doing an approximation of what your graph looks like. Questions on that one? Okay, third and final type of problem in this section is actually finding the parametric equation. So we're working in the reverse order. For these, you're going to actually get given two equations, one that has a t in it, one that does not. You will take the one that has the t in it and plug the value in to the other equation. So you will solve, so let's say that the x is the one that has the t. You will solve it for x, and then you will take and plug that into the x value on the other one. Let's say that the y equation has the t. You'll take and solve it for y, and then take and plug that into the other equation, which will have a y. Your end result should be two equations, one with an x equals and one with a y equals. They both need to have a t because we are creating the parametric equation. So we're working backwards. So last example, example 5, is actually two parts. Like, don't let this confuse you. Okay, those are two totally separate questions. The directions are just the same for both. So it says find a set of parametric equations to represent the graph of y equals 1 minus x squared using the parameters, and a is t equals x. So the two equations given to you for the first one is y equals 1 minus x squared, and the other one is t equals x. So which variable has t? The x. And it's already solved for x, so that one is actually done. Now I have to find the y in terms of t. So if x equals t, then I'm taking t and I'm plugging it in the place of the x, and I get y equals 1 minus t squared. And you can actually just leave it just like that. Okay, you could switch the order if you want to. Negative t plus 1 doesn't matter. All you're doing is making sure you're solving for the other variable. So there would be your parametric equation. So if I had graphed my initial shape, which would have been a parabola pointing down with a vertex at 0, 1, and then I graphed these two, they should overlap in some way. Again, these two might be restricted depending on what we plug in, but the overall shape should be the same. Okay, now look at B. T equals 1 minus x. Again, you're still using the first one, which is that y equals 1 minus x squared. So which of these equations already has the t? The second one, right, or the x. So I'm going to solve it for x this time. So I would say that negative x equals t minus 1, and x equals negative t plus 1. So that's the first one. And again, order doesn't matter. You can make that 1 minus x, 1 minus t if you want. And then I have to take what x equals and plug it into the first equation in place of the x. So I'd get y equals 1 minus a negative t plus 1 squared. This needs to get simplified. So I can either expand and FOIL that, or I can use my shortcut that we reviewed in the rotations, which is square the first term, square the last term, multiply the two together, that'd be a negative t, and then double it, that's be a negative 2t. Oh, this is square. And then I would distribute my negative, so I'd get y equals 1 minus t squared plus 2t minus 1. The positive one and the negative one cancel out, and I get y equals negative t squared plus 2t. That's my second equation. Question. So obviously the basic skills are the same things you've been doing forever, right? It's plotting points, connecting them, that kind of thing. There's 3 different types. That's it. That's all you're going to get. You got to pay attention to domain restrictions. You got to make sure that your arrows are on your parametric equations when you're graphing them, and then you don't need them obviously when you're doing the estimates. But you want to make sure that you would be able to do that. Questions?
But these is always going to be a parabola, right?
No, it could be like a square root function where it won't go fully around. It could be half a circle. They could be all different kinds of shapes.
Okay.
Most common would be the parabolas. Yeah. Okay, WebAssign is open.